So the first part of the demo that you guys are seeing is we are showing here the VSD screen where I'm showing that we have actually a virtual network, right? And on the virtual network we have a couple of virtual machines, and we can identify these virtual machines, right? They have their names and stuff like that. This is the standard Nuage, if you want, overlay interface. From these virtual machines, from this information, we just get the overlay information. That's nothing new, but it's important because I'm showing that so we can correlate it on what is happening later on. So this first part here is what we call the inventory manager. The whole platform, we call it the Virtualized Services Assurance Platform. This is the name we gave it. And we have the inventory manager. And if you see here on the inventory manager, here are essentially the virtual services that have been created on VSD. They have been recovered again over here. And out of this virtual service, you can go and see this particular service is being affected by these controllers, first of all, these SDN controllers. You can see the underlay, the physical routers essentially that are touching this virtual service and what they are. And you can see the virtual switches that are touching this virtual service on the bottom. We have the refresh button there, it starts it. So here, for example, we are seeing the virtual services controllers. We're seeing the underlay routers that are implementing this virtual service. And then we can go on the virtual switches and click on the individual virtual switch. And we will be able to see all the virtual ports of this particular virtual service that is on the left right now that is activated on the specific vSwitch, right? So how a specific vSwitch. So this gives you essentially a little bit of what is happening in the data center. And similarly, the inventory topology now allows you to see that I have the controllers, that they have these virtual switches and these virtual machines, and how they all correlate with each other, right? So this is one part of the application. The second part now is that we have what we call the service navigator, where what I'm showing here, and I'm going to stop it a little bit. What I'm showing here is, in the Nuage context, we have organizations. So we have the organizations because it's a multi-tenant environment. We have organizations. So for each organization, we have that this ABC bank right now, it has this virtual domains. A virtual domain is a layer 2/layer 3 domain, if you want. So we have here, for example, domain 1 is just a layer 2 subnet. The VRF domain and L3 domain, from the names, is of type layer 3. So it consists of multiple subnets, and it consists of multiple virtual subnets, if you want, right? So for every one of these domains, we can see now a list of the virtual machines. And on this list of virtual machines, we can immediately identify the functional state of the machine out of these events. But the most important information is out of correlating the routes underneath. We know the reachability state. Can somebody actually reach this virtual machine based on the topology? And on the bottom of the screen here, what we have is we have a recreation of the physical map. Right? This is the physical map of the network, and it will become a little larger, I think. So this is a physical map of the network that shows what are the routers and how they are interconnected. Right? This is a multi-layer topology. We didn't do just an ECMP topology. We did a multi-layer topology over here.
Can drag that out of the way.
Can I?
Yeah.
There you go. Thank you.
Thanks.
Okay. Right. So we have the multi-layer topology. Now, what happened here is we have these buttons here that once you select a service and you have the topology, you click the one button and you see with red color here, where is the overlay that is touching this physical topology. And what I'm going to do is I'm going to click the additional buttons here, and they will show two more things. They will show who is the upstream router for this topology, for this virtual network, right? The VXLAN usually, somehow it has to go out on the physical infrastructure. So it has to use a hardware VTEP to go out. So it will identify what is the upstream router for each particular VM. So I'm going to click on the VM here. And you will see this is highlighted in blue. Unfortunately, it doesn't show so well maybe, but this is blue. So this is essentially the upstream router for this topology. And then we are going to show also where is the SDN controller, because notice another thing, the Nuage SDN controllers also participate in the underlay topology, right? Because the Nuage SDN controllers also create this topology to do next hop tracking. So actually, what we are seeing here is that the Nuage SDN controller is also part of the topology. And we are showing the Nuage SDN controller with the green there, showing that actually the controller is there as well. Now, in this example, I have another network that actually has a fault, and you will see that the fault has been discovered over by this network. Now, as part of this, what I'm going to show is I'm going to show the historical events now. So the tool is actually collecting all the events that happened in the past, when they happened and what happened, and you can see them for a particular interval of time that you are interested in. So you can see now a whole bunch of events that are happening here, right? A BGP prefix that was withdrawn, a vport that came up, a vport that came down. Any event that happens in the network that is related to what? Is related to this particular service that I selected up there, right? So any event that has affected this service can easily be figured out over here, right? So I can immediately understand how the events in the network, whether it's physical topology, whatever is the event, correlates with the health of my service over here that I'm running. Okay, and here on the right, you get even more information about these events and what is happening on these events. Now, here I'm showing you essentially a correlation of events. Right? So we see here that a vSwitch controller came up. The result was that the port showed up on the upstream router, right? The result was actually a VM actually came up. The corresponding port of the VM came up, and the BGP prefix was flapped. This is actually a BGP prefix on the overlay now, right? Because of the Nuage controllers that shows now how the service has created a BGP event on the overlay, right? This is not an underlay event. We'll show later the underlay events and how they correlate.
How do you know in that case that it's a overlay BGP event versus an underlay one? Is it a coloring or is it just by context?
It is identified as a BGP EVPN event, right? Or a BGP physical event, okay. Right? Here I'm jumping over to the fault manager. And the fault manager here shows you the different types of alarms, and alarms can be filtered, right? We have major alarms, warnings, information, right? All the standard things that you should expect over here. And you see here, like a major alarm is that a BGP prefix is unreachable, right? This goes like to a major alarm. You will get warnings of an interface down, essentially, because when you do an interface down, right? You have to classify which one of these things is actually a major alarm, which one of these things is just a warning that might result to the major alarm, right? Is the stuff that we talked about earlier. So what I'm going to do here is I'm going to show you my topology, and I'm actually going to first create a failure. The failure I'm going to create in the beginning is just a virtual machine. So what I have here is I have a hypervisor with a bunch of virtual machines, right? These are the machines that we saw earlier in our demo. And what I'm going to do is I'm going to try to stop one of these virtual machines. So I'm going to destroy one of these virtual machines. And then I'm going to go back to our tool, and you will see that this virtual machine, obviously, from the Nuage perspective, it's down, right? It has no state at this point. And then when we go to the observation tools, and we search again for these machines and the updates, you will see immediately here that this virtual machine, if you notice here, is identified here as having no state anymore, right? Because it disappeared from my system. So that has been captured immediately and can be visualized by the operations guys.
So if you're just the network operator, you'll know that the machine's gone away because there's no state. Exactly. They've destroyed it, or I mean, they would have to have destroyed it, not just shut it down.
And then you will get an informational alarm here saying that this machine at this time was actually destroyed, right? And this is the mean time to pointing the finger now, that if somebody tells you, oh, but it was not working after that, you come and show that, and life is good after that, right?
Good questions like, was it working after 10:20 on last Friday? And they go,
Is your perspective about the VM availability strictly what you can see from the vSwitch, or are you hooked into libvirt as well?
Is what we see from vSwitch, but what we see is actually, the event is actually from libvirt. Is our agent on the machine listens to libvirt events. That's why how it knows VM down, VM up event.
I see. Okay. From the libvirt perspective, this machine is still defined, it's just not running?
Correct. It's still defined, not running. And what happens is the moment the libvirt event is taken, it's sent up to our controller withdraws the routes, does whatever it does, and then it sends the alarm up to the monitoring tool. Okay? Here, and then what I'm going to show here is on our other view here, right? You will see that the VM shows as in reachability state as not reachable anymore, right? So if you see it from the other visualization perspective, that on this service, on this particular service, the VM is not visible anymore. Now, the next step that I'm going to do is I'm going to create a physical network failure. But before I create a physical network failure, I need to stop for a minute and show you this topology. So the actual physical topology that we are running, it looks like that. We have 3 autonomous systems. This is essentially the top of rack switches here, the top of rack switches, and there is a core router here. And the top of rack switches, we have actually 2 Arista switches and 1 of our own switches. The core switch is it's an Alcatel-Lucent service router. Here we have another similar infrastructure where we have just 1 top of rack switch and the core switch. And here we have another core switch where we have our controller there, but we have another core switch. So we're simulating 3 autonomous systems in reality, right? Not just 1 autonomous system. And what I'm going to do is I'm going to come and destroy this link, right? I'm going to, behind this top of rack switch, this link between this top of rack switch and this SR, I'm going to bring it down. There is a whole bunch of VMs running on this hypervisor, and I want to see how the tool is going to figure out the fault and what it's going to do with this fault discovery after that, right? So that's what I'm showing here. I'm going to come here and I'm going to log in on this router and I'm going to shut it down. I'm going to shut down the interface. So I'm coming here to this router, and this is the same interface we saw there. I'm going to do the standard. So now the interface came down, right? And because the interface came down, a whole bunch of things are going to happen now, right? So what's going to happen is if we go back to our fault management perspective, and we get a new view of the things, you'll see that several critical alarms are raised immediately, right? And these are the alarms that are saying that essentially, I have lost the site, and because I lost the site, I lost all the services. All the services now are under attack, essentially, right? And this is the first indication now that something is going wrong, right? You got the paging, if you want the paging mechanism working. And now, by clicking on the show impacts, you see that the virtual switch went down. Essentially, it was withdrawn. And because of that, I reached the site. And now we're going to see actually that because the virtual switch goes down, actually here, if I notice it, you will see that this is, I need to go here, okay. There is an IGP prefix that is unreachable at this point, that's the alarm. Because the IGP prefix is unreachable, the virtual machine, the virtual switch is down. Because the virtual switch is down, the virtual machines are down, the corresponding ports are down, right? The fault has been propagated. So I know now as an operator that...
Yeah. This is actually a root cause analysis because you're building a graph from the network architecture based on the routing database.
Yeah, I see advantage because, for example, if my storage disappear, so it affecting a whole bunch of VMs,
right.
The VM folks or the server folks will come to us and say, hey, we have a network problem first, but because you have tapped into the underlay and the overlay, if I want BGP VPN, so you have a full picture immediate. You can say, hey, I don't have any problem with the network, but yeah, your VM disappear. Either your host is dead,
right,
or maybe a storage problem.
Exactly, right. And then in every point, wherever you go over the action items and you see which exactly it is, right? So you will get this machine, specific machine that has gone down and so on. And I think that's the end of the demo part. So you got an idea a little bit of how this tool is trying to essentially become the debugger for the network operator, right? We solved the application designer guy's problem. We solved the security guy's problem, if you want, that, you know, this is my policy, try to do my policy. Our next step is to make this thing operational in the network, to help the operations guys to make this real, right? So that's why I think it's we're very excited about, and for me the biggest thing is we have managed to create that by just, you know, just using whatever is available there, right? It's when you are given lemons, as they say, you make lemonade.
Yeah, so you poll the available information, SNMP, routing, UPIA. Exactly. You're not injecting, you're not becoming a BGP route, you're just listening, right? You're iBGP listening or OSPF listening, and that gives you the extra data sources that you can then bring smart software to play. Yeah. Makes sense.
That's it, guys. Any more questions?
You're listening for a whole lot of events there on the routing table. Now, there are companies in the past that have specialized in doing nothing but that and then generating reporting data and information about that. Is that a direction you guys are heading in with all that data you got?
It is part of our solution, right? We see it as a complete solution. As I said, our goal is to make virtual networks operational in large environments, and we see this as a necessary piece. And people are looking for all the pieces of the solution, right? People are not looking for you know, only part of the equation. I have talked with a lot of people, a lot of accounts. Everybody was asking me, yes, okay, all this is good. Can I operationalize it? Can you show me the tools? Can you help me with that, right? You have to do the...
Yeah, this is the soup to nut. This is the soup to nuts vision of SDN, is that if I design it here, then, and as you say, you've solved the design problem, you've given me a graphical console, I can change things around really easily. If it breaks, though, the abstraction of overlay from underlay means it's very hard to troubleshoot, or could be, depending on how you look at it, very hard to troubleshoot what's actually going, you know, where are you going to go to do a packet capture if you get to that level of, if you're at the nuclear option of having to do packet captures to do troubleshooting, where are you going to go to get those packet captures? This puts you back in that information flow because you're saying, I can tell you where, to some level of granularity, ECMP, you know, within limits, ECMP networks, obviously you can't capture all the packets on an ECMP, but you can start to say, I can see where things are going. And that's, as you're saying.
It's phenomenal. You know, this could be another startup on its own in terms of, you know, what you're showing.
I know. So, but again, I'm completely transparent with you guys. I don't think it's easy for people to do these things. We used a lot of stuff. The same way, in order to build Nuage, we used all the routing protocols from the service provider side. For this thing also, we used a lot of capabilities for the service provider side because these tools were available there, and we used a lot of the capabilities from there, and we got a lot of code, right? The code that takes years to build, right? That's why sometimes I say we have an unfair advantage, because as long as we have an open mind on what we borrow, things move fast.
Yeah, but I mean, there's no reason here your correlation engine can't extend into new protocols. So you alluded to things like netconf and, you know, whatever it is that comes on in the future, it's all raw meat for the correlation engine. You know, not a simple thing to solve, right? Because you've got to write it into you've got to establish the correlation parameters and the algorithms around that. But you're not stuck here. This isn't closed as such, in that you're only doing this a special way. You might be using open data, but there's no reason it can't be extended into new data sources either.
And I know that our sibling products, right, on the service provider state, they're building netconf stuff as well, right? So I know what I'm going to do. I'm going to do a git pull request. I'm going to get it.
Yeah, you will.
And I'm going to adjust it, right? But that's what we do, and that's the advantage we have. I think that's our unfair advantage. If you ask me what is Nuage's unfair advantage, it's exactly that, right?
Yeah.
But would you entertain, let's say in 6 months, let's say you support netconf, would you support this as a standalone product?
Potentially, yes, and we'll offer it to people as well, right? It is being sold as a standalone product, and potentially we will give it to people. Obviously, it gets much more information when combined with Nuage and potentially with other, as long as somebody has an open way of doing this, it will work, right? We can make it work.
As long as it's an open public. Let's just say it could be an API which is proprietary to one company, but published. That's still open sometimes.
Right, so as long as they're open and you're extensible, you can.
The challenge a little bit with this is that people that see us as competitors will be less than willing to open up to us working with that, right? There are some commercial challenges with that.
Well, there's a lot of APIs that are iterating very quickly too. They might be open, but they're effectively useless because just because you can read the API and 2 weeks later it's gone, doesn't make it a useful API. So it's a complicated industry. All right, I'm pretty impressed. I think this is a real step forward for SDN in particular.